Good morning. I've got some very exciting news for you guys. So, the exciting news is that today is the last day of new material. From now on, we're only going to be, we're going to take a benchmark. On Thursday, we're not going to take a test on this stuff besides the benchmark. And then we're going to prepare for the final, which is next week. My plan is to put the final out on Thursday, so to prepare with you next week on Monday through Wednesday. We'll be doing a huge Jeopardy game on Wednesday, but on Monday and Tuesday we'll be doing like extra credit to boost your grade. So there'll be kind of an extra credit packet that you'll get. And you can boost your grade through that and ask me questions. You'll have 2 days to do that. And then we'll take the final. The final I'm going to post next Thursday, and then it'll be due the following day, Friday. So you'll have 2 days to do it. It's not going to be that long. It's going to be 11 questions, and you get to cross one of them out. So not bad at all. Hopefully you will do your absolute best. Okay, so today is the very last day that we're doing something new, and we're going to do something called elimination. So if you remember, there are 3 ways to solve two lines crossing, right, to see where they cross. The first way is to just graph them and then see where they cross and write down that point, or, if they're parallel, then it's no solution, or if they happen to be the same line and they're right on top of each other, that's infinite solutions because they overlap every single spot on the line. The second way is by substitution, which we did on Tuesday. And then that's an algebra way. And then the final way is another algebra way, and that is by elimination. So 3 general methods. We're going to start out, we're going to do 4 problems today. Here's the first one. So make sure you write it down. It's very important that you're doing these with me. Can't say it enough, guys. Gotta actually try this stuff. Can't just watch it. So, now let's talk about why this wouldn't make sense to do by graphing. Well, if we're going to do it by graphing, we have to make it look like y equals mx plus b so that we can graph it, and then we have to solve both equations for y, and you can tell right now that's going to get horrible. There's going to be lots of fractions involved. I know you guys don't like fractions. Fractions actually aren't the devil, but it's difficult. And why make things difficult when you don't have to? The other way is by substitution, where you solve for one variable and plug into the other one, but again, that's going to be nasty. We're going to have lots of fractions. But this one is set up for substitution. So I'm going to write out the steps over here. This is kind of going to be a weird moment here because I'm actually going to skip step 1 because we don't need it on this one, and go right to step 2, and then we'll add in step 1 later. So give yourself some room, put step 1 down, but give yourself some room to write it in later. So, step 2 is to add the equations together. One variable should cancel out if you did this right. That's why we don't need step 1 for this problem, because on this one they actually do end up canceling out immediately. So that helps a lot. Let's make that a little clearer. Try to at least. Oh, my autofocus not working? There we go. Okay, so if I was to add these equations together right now, just like if I was going to add things normally, I would just kind of add different columns. Like the ones place and the tens place and stuff like that. Do you see right now how 5y and negative 5y, they're going to cancel each other out, because if you add 5 and negative 5, you get 0. So those ones are going to cancel out. This one is 3x plus 5x, which makes 8x. And then over here we've got 11 plus 5, which is 16. So now I have the equation 8x equals 16. So that was step 1 right there. Or sorry, step 2, because we didn't have a step 1. Step 3 is to solve for the remaining variable. I grab my phone. Apparently, some people are trying to contact me, so I want to make sure to turn that off. Sorry. Okay, so if I'm going to solve for the remaining variable, the only thing that's left is x. By the way, it's not always the y's that are going to cancel out. Sometimes the x's cancel out instead. So I'm going to divide by 8 on either side, which leaves me with 2. So now I know x is 2. All right. Step 4, this is just like substitution. You're going to plug that answer into one of the original equations. And solve for the other variable. Okay, so I'm going to plug in 2 into one of the original 2 equations and solve for the remaining variables. So I don't know, it doesn't matter which one you pick. I guess I'll pick the top one. So I end up with, let's see, my top one was 3x plus 5y equals 11. So now which one do I plug it into? Well, it says x equals 2, so I need to make sure that x is 2, not y is 2, just x is 2. And again, you don't always plug it in for x. It depends on what this says right here. So since it says x equals 2, I know I'm plugging in for x. So this is 6 plus 5y equals 11 minus 6 on both sides. This is step 4. Here was step 3. Okay, so 5y equals 5, divide by 5 on both sides, we get y equals 1. And then the final step is to write your answer. Remember, the answer to these are basically you've got 2 lines that are crossing. So where 2 lines cross is a point. So write your answer as a point. So your answer should look like x and y in parentheses. So my answer is going to be 2, 1. That was step 5 right there. Okay, let's try example 2. 3x plus 6y equals 30, and 5x plus 6y equals negative 6. Okay. So, now I'm sure you're looking at the y's right now and going, ooh, they cancel out. But they actually don't, because if you took 6 plus 6, you'd get 12, not 0. So we need one of them to be a negative 6. So that brings me to the first step that we're going to add in, which is to multiply one or both equations by a number, so that when added together, a variable cancels out. Now, there's lots of different ways to do this with these problems. Technically, you could do this for x or y for any of them, but there's usually an easier way, and mathematicians pick the lazy way because mathematicians are lazy. So I'm going to try to get rid of the y's because the x's look too complicated right now. So for my first step, I'm going to pick one of the equations. I'll pick the bottom one, and I'm going to multiply everything by a negative 1. So it's like I'm going to distribute the negative 1 to all of them. And that will make this a negative 6y, which is what I want. That's my plan. So I'm going to just rewrite the first equation first. And then the second equation, I'm going to multiply everything by a negative 1. Now that looks a lot better because now I can cancel out the y's without having any problems. Before, remember, they would add up to 12. Now they add up to 0. So that was step 1 this time. Step 2 is to add the equations together. So I'm going to add them together. So the y's cancel out just like I planned. That's what I wanted to have happen. And then I'm going to take 3 plus negative 5 makes negative 2x. And that 30 plus 6 is 36. Yeah. And then if I divide by